push the button when you arrive, plug your laptop in.
Yeah, pretty much just plug your laptop in, push the button, and start recording.
Hi everyone, welcome to Exploring the Web Audio API. The goal here is to talk about some of the basics of the Web Audio API, why we use frameworks for these kinds of things, and what makes development hard. Boy, I did not edit this very well, I apologize. I work at a company that makes software as a service targeted to nonprofits, specifically small independent schools. My wife and I live in a small apartment with 2 kids. Here's my link info. We've outgrown our apartment, and we sort of adapted some strategies to deal with 2 kids and 2 adults living in a small space. Those are my kids. I believe that says the Hypnotize Lab right here. And it alternates between come in and keep out. Our sound machine broke recently. We had one of those like little ones we plug in and make sound. And I knew there were like hundreds, maybe thousands of sound machine apps on the App Store or online. But I decided to build my own because why get something for free when you can waste time building it? The goal here is find sounds, make a browser interface, implement looping and volume control. So one of the first things I discovered is like good sounds are hard to find. I went to freesound.org. It's great, they've got a lot of stuff, but the quality is really mixed. And I'm not a sound engineer in any way, but you can tell like pretty quickly this is a terrible sound. But there are some good ones, and it's really great, and you should go there and buy a t-shirt. Okay, the Web Audio API is basically a browser-native modular system for building audio applications. It works really well hand-in-hand with HTML5 audio, which you might be familiar with. It's just the audio tag and the associated things that come with that. It also can work on its own. The demonstration that I'll show today is uses just the Web Audio API, and in the process of building it, I realized how much easier it is to do with just the audio element. But we'll get to there. Sorry, IE, you're not invited. You're not invited. If you do need to do an audio application and support IE11 or earlier, JPlayer is one that I think NPR uses, or they did a couple of years ago at least. But it does have pretty broad support across the board. That's a lot of green. We're doing audio, so I had to do some audio effects. So audio context. This is like the thing that all the action happens inside of. It represents the audio processing graph, which we'll look at in a second. And it's sort of the thing that everything else is contained in. I could see applications where you'd use more than one. I'm using just one audio context to start. Here's my audio context. Firefox Developer Tools has a built-in web audio viewer, and they give you this nice view. It's not super useful, but it does provide a nice overview of what's going on. This is what we mean when we talk about a graph. So these are the different nodes on the graph, and we're going to talk about these 3 types of nodes. And this would be good to keep up while I talk, so why don't I just keep it up? We've got, for my application today, I've got 4 sources. So this is basically the sound, the different sounds that I'm putting together. Gain nodes are basically volume control. And we've got each audio node has its own gain node. And then there's like what you call like a main or a master gain node. The audio destination is basically the speakers. It's totally, opaque to the browser. Is like you hit the destination and then the browser talks to the actual hardware through the operating system, one assumes. So audio node is like the generic leaf of that graph, right? So the source is the audio buffer source node, which I'm going to be fetching, but that could also be pulled from like an audio tag if you're using HTML5. There's also other types of nodes. There's oscillator nodes, so you can make your own. I think I spelled oscillator wrong. There are oscillator nodes, which are basically sounds you can make yourself. So if you want to create a full synthesizer, which I did start but didn't finish for this talk, you can actually make your own sounds with an oscillator, which is pretty cool. Analyzer gives you ways to do visualizations or other things with the audio, and then the gain, which is again the volume control. There may be other things. I haven't explored every part of this API. The gain node is the volume. Sort of describe what I'm doing here, which is each source has its own volume control, and then there's a master volume control. Audio destination node. So this is the output. Basically, you can think of it as the speakers. Speakers. It also is possible to make an audio destination node right into a file. So you could like take your stream of audio and output it to a file or some other source. That could be your audio destination. So array buffers. This is not part of the audio API. This is just part of the browser. It's an object used to represent a generic fixed-length raw binary data buffer. I like to think of it as a string of ones and zeros. It's just the raw like high-low signal coming through the wire. Right. So that's the buffer. We'll maybe talk about it in a second. The audio buffer is basically a specialized view on that string of ones and zeros. So that string of ones and zeros, you don't know what it is. It's just binary. But you need like a proper view that can look into that stream and turn it into something useful. And that's what the audio buffer does. It gives you some methods and properties that are pertinent to audio. This is. All right, so this is a quick rundown of what we're going to do. We're going to fetch the data from an external file as an array buffer as part of the fetch, the response object. We're going to decode that data into an audio buffer, and then we're going to hold on to those audio buffers. So we got 4 of them. We're going to hold on to them, and we do that because I want to be able to loop. I want to be able to play and pause. So I want to be able to like recreate the audio over and over. When we're ready to play the sound, we're going to create an audio buffer source node. So again, that's those leaves on the tree. Load our audio buffer into the node, connect with gains, connect to the destination, and then call play. Sounds easy, right? Where's it? Okay, so I ran into some problems. I built this really quickly, and I was like, this is great, it's working. I'm going to be able to sit back and watch TV, and my kids won't hear me. But, I built it in Chrome, and then I wanted to play it on my phone or iPad or something that I could, like, stick in their room, right? Immediately, like, failed. It just didn't work. I think I work in frameworks all the time, Node, React or Angular or whatever it is, and I forget how hard it is to get things to work with raw JavaScript. So here's some of the problems we'll go through. File type, this one maybe should have been obvious. I was saving OGG files, or I get confused if it's OOG or OGG. I think it's OGG. This is a nice high-quality audio files type that most browsers support, except for Safari. So pretty simple solution was to have multiple file types. I could have just gone with MP3, but I'm sort of thinking about like, what if this was a bigger application? How would we solve these problems? And so I have a pretty simple function here that basically takes the file name in, concatenates it with a dot, and then checks if we can actually play audio OG. That's sort of my default in this situation. Play the OG, if not, put MP3. I'll show you later why this is so specific to what I built, and if I were actually building a production application, we would think about doing this a different way. Oh, right, here's the alternative. So if you have HTML rendering on the back end, why not just do this? And this is actually how I implemented the sound effects on this slide, is just like audio with different source nodes. And the browser will basically pick up whichever one it can and play that one. So this is probably, this is a nicer solution if you're able to render HTML. So like, for example, oh yeah, there, I misspelled it. This could be MP3, it could be WAV file, it could be, there's a bunch of other kinds. Yeah. Totally unrelated, but this took me an hour. If you put a click handler on a button, Safari won't recognize a tap as a click unless you have inline style cursor pointer on it. It might not be inline, actually. I put it inline. I haven't tested whether you need to not be or not. But yeah, that's awesome. Connect. So this is the method we use to connect all those nodes together. In Chrome and Firefox, the connected node is returned from this method call. Safari returns undefined. I figured this is like the end of the application build, and I was super fed up, so I didn't figure out any nice way to do it. So instead of doing this, which is nice, I'm just doing this. There probably is some way you could. There's probably something you could do. Maybe wrap the connect function in a function that returns the connected node, but always. Make me promises. Okay. Just want to make sure it got stuck in your head. Okay, promises. If you don't know much about promises, a promise is an object that represents the eventual completion of an asynchronous operation. Being a jerk, sorry. So basically, it's an object that will eventually resolve to something, either a success or a failure. You might see them. You'll see them in promise chains. So you run a fetch, and then if you get a proper response back, you go to the then function. So you get your response, and then you do something with the response. To get to the next one, you want to return another response, which we're going to see in a second. So you have then response, do something with your response, then you have the data, you do something with your data, etc. So we're still in the problem section. Decode audio data. So this is basically the way that we take that array buffer. We take that array buffer that we got from fetching the file, and we decode it so that we turn it into an audio buffer. In the documentation, the MDN documentation, the return value says, hey, it's going to return a void or a promise object that fulfills with decoded data. So we know we're returning a promise here. This is great. We can use it in our little promise chain. So fetch the sound file that we want. Then with the response, turn the response, or run the array buffer method on the response and get the audio buffer back, or get the buffer back. And then we can run the decode audio data. Looks sweet, right? But Has anybody been to this website? This is, oh, bummer. Okay, well, I'm glad I did a screenshot. This is the WebKit developer documentation for Safari. And this is basically it. You can side scroll this little thing and see, get a little bit more information about the method, but there's very little there. The thing I didn't do is talk yet about MDN and Mozilla Developers Network. And I should have front-loaded that because it's an amazing website. It's got all this information about everything, and it's where I went for most of the data. Anytime I say, oh, in the documentation, that's what I'm talking about. It took me a while to figure out how to find this page and then what this actually meant. There's no description, no overview. And this is really typical of the Apple's docs. I don't want to slag on them because they are providing data, which, for example, Edge does not. But it's really limited. Long and short is Safari does not return a promise from this method. Instead, it relies on callback functions that you have to pass into that decode audio data. This is a problem for me because I really want to do the promise chain thing. So I need to figure something out. So this is a nice solution. And it can be used for anything. It can be used for I think the example in the documentation is for set timeout. And basically the idea is you're going to wrap, you're going to make your own function that wraps the API function, and you're going to return your own promise. So this is my function name. It takes an array buffer that comes in, and it returns a new promise. That promise takes resolve and reject. So this is basically whatever function is in the next then is the resolve, and reject is going to be in the catch block. And for this example, we run the decode audio data, and we pass an array buffer, and then here's our callbacks. Really simple. So then this works in Safari. Make a request, get a response, take that buffer, decode it through my custom method here, and then we get another then block. And we have the decoded audio, basically, is the point. This is my big takeaway. This is sort of the stages of being a web developer. Googling, I think W3 Schools is in there somewhere. And then each browser has its own documentation site. You need to know where they are. You need to get comfortable with them. Here's a list of some API documentation. Google, Apple. Microsoft, interestingly, just literally links to MDN, which is totally fascinating. And not a terrible strategy. I don't want to slag on them because they actually include a lot of information about upcoming stuff, but I couldn't find any real API documentation. I guess that what they're trying to do is align themselves as closely as they can with Mozilla. And there's Mozilla. In the MDN documentation, I noticed, oh, wait, they have the older callback syntax. So you can just skip that other device and just read MDN. And honestly, that's true for... I jumped too fast in that. That's actually true for the connect function also. They had a little thing saying, some browsers return undefined, which is pretty awesome. Like they're basically documenting the other browsers for them. Working directly in the browsers is hard. You can write directly for these APIs, but I'd say really like for prototyping, for playing. I am writing something for work that has like super limited scope, and I'm probably going to write it straight JavaScript. But I'm like, it's got to be well tested. There is going to be a polyfill. I just don't want to load a whole framework on a page. Here's some of the web frameworks, web audio frameworks. One of the things that we talk about when we talk about frameworks is like React or Angular, and we're really talking about DOM. Those are one set of web frameworks. Those are DOM manipulation frameworks. But I want to point out there's all this other ecosystem of the browser. There's web audio. and there's Canvas. There's all these other cool tools that are within the browser. And you should learn them, and you should learn which frameworks work really well for them. Okay, autoplay is important to talk about. I think after the panopticon of Google, I think the worst thing about the web is autoplay videos. And Chrome has actually implemented a thing where they basically are preventing you from using this API on page load. You have to do some sort of gesture, some sort of click to get in there. Firefox has a setting, I believe, that you can set. It's like you can choose whether or not to block autoplay. I'm not sure about Safari, but we all know it's super intrusive to have autoplay, and it is a thing that can get you hung up when you first start playing with this stuff. You're like, why isn't it playing? It's because they're basically blocking it. Why don't we look at a little code? For some reason my keystrokes don't work. Oh, that's my talk. Oh, I should show you the actual machine. So it's really ugly. But this is the idea. You can play, adjust the volume of each of these, bump up the main volume, add some chirping birds. I like the training. So, pretty simple. Clearly, this is something I will probably never use. I think I did use it once for a nap. Why don't we walk through some code? We'll start at the bottom. Oh, no, we won't. We'll start... we'll start here. So this is kind of a funny way of doing this. I think I had defined this in the first file. But this represents yeah. Oh, you can't see? How's that? It's okay? Yeah. So this represents our backend, basically. So basically delivering JSON with some information. We got our path, our title, file types I ended up not using, but you could imagine that being a thing. So on load, we're going to fetch our sounds. We're actually going to create the DOM and everything on the fly. So we fetch the sounds. This is returning an object that has a bunch of values. Leave this open. Yep. An object that has an array of values. I'm doing this. This seems silly, but I'm basically JSON parsing the text. I think you can just call the JSON method on the response object, but someday I'll be good at JavaScript. And then we're getting the data, and then we're instantiating a new audio player. So this is my custom object. If you can't tell, I wrote a lot of PHP. And here's my audio player object. So this is going to be the audio. This is going to have the audio context, and it's going to hold references to all the different tracks. It's going to have those. Is it, or is it just going to write them? I forget. We have our audio context, and we're passing in a list of tracks. So that's that array of objects, right? So this is just an object with a file path and a title. We need to create our master gain here, and then add. Oh right, and this is just setting up the volume listener for that main volume slider. Sorry to jump back and forth like this. So we have our audio player. It's just holding those track values, and it's got a master gain. That's it. We're going to take that and then pass it into a new function, and then we're doing a little for each, and then we have this method on our audio player called write to document. write to document is where we're instantiating now a new track object for each of these sounds. Just sort of passing in the audio context, so I need to be able to connect the tracks node to the main gain and eventually to the destination. This is our constructor for the track. Doing a lot of thising. I want to have reference to the audio context for each track. And I actually create a little HTML. So one of the things I did here, right, is I'm avoiding all frameworks. So I'm not using React. I'm not using any of these very handy frameworks that usually help with DOM manipulation and stuff. I thought that was a smart idea, and it made it so much harder to do anything. You have to be very, without like a framework, you have to be very imperative in your program. You have to be like, hey, do this, and then do this, and then do this. And when you're dealing with like click handlers, it just starts getting like really convoluted. Hopefully this isn't going to be too convoluted. Yep, we have our main gain node. We're connecting it to main gain. And we're creating a local gain also. So each track has its own volume slider. And then we, of course, need to fetch again. So we do another promise chain to actually fetch the file itself. And this is what the talk sort of focused on, was fetching the buffer, decoding the audio, and loading that into our audio buffer. I do want to show you a silly little thing. Where is it? Oh, this is our create sound block. So like I said, I wasn't using a DOM library. So I made a little, this is called a template literal, which is like a fun and super sketchy way to write to the DOM. Like this title, like if this were user input, they could put whatever they want, right? So don't do this. But it is really fun and in a cool way to make HTML on the fly. It basically allows you to like write HTML as a string and then insert values as you go. Yeah. And then again, a lot of imperative programming here, right? Like do this, do that, do this. Basically, actually, what I'm doing here is actually adding the event listeners to the buttons, to the sliders, and I've got a play and a pause button separate. And track. So we've done all that. We're fetched and we're ready to go. We have and then we have these two play and pause buttons. Oh, and I'm not really catching anything here. I started working on actually handling errors properly, but I'm not. So don't use this as a way to handle errors. So we've now written to the DOM. We have our listeners there. We have our audio buffer in each of those track objects, and each of those DOM elements has a listener that will call that particular track, right? So then you just run through the steps. You take the source. You create a new buffer source. So that's our node. We add the audio buffer into that node, run the connect, and then hit start. Audio buffer source nodes are ephemeral, and you can't restart them. They start once, and then you can stop them, but you can't restart them. So we basically need to recreate those each time someone presses play. Play or like pause, basically. It doesn't exactly destroy it, but that's essentially what happens. You should know more about that. Yeah, that's it. Any questions?
Do you know, like, is it possible to do a pane, like a buffer to a stream? Is that a whole other universe of pane, or is that okay?
No, there's totally, streaming is not bad at all. You could definitely there's definitely objects and methods or functions to help with that stuff. It's not working currently, but I am making a little audio recorder which you can, you basically, you're taking the stream from the computer, so someone's speaking, saying their name or whatever, and you can take that stream and capture it and save it to file or stream it somewhere else. Yeah, it's definitely part of the API. Yeah. Oh, I wanted to show you. Did I show you this already? Where was it? Oh, I think I have it. Yeah. So this is just an audio tag. It's so easy, and you should just use these. So if we look at it, there are some disadvantages, and I don't want to like totally do it. But basically, I put the controls on. That gives us the native controls, the play button. The loop has set that to true, so it keeps looping, and then I have the two sources. And this essentially works. There's even a volume control. It's pretty sweet. It's going to loop. It loops. The only issue with it is you can't crossfade, which I didn't actually end up doing anyways. But that would be there's certain things like that where you can't get as much control on it. But it does work in Safari. So you don't have volume control. Again, there are definitely limitations, but boy, it's nice. And you can also use that. You can use them in conjunction. So there is a method to basically pull the audio source from the audio node. Yeah.
Did you do any experimentation with like altering sounds?
I started actually making like a little MIDI synthesizer, but I didn't get very far. I was using Tone.js, which is one of the frameworks that I mentioned, and they have so many. It's so much easier. There's so many. Like you can be much more clear about what you're trying to do. You don't have to build everything from scratch. I didn't do any like oscillator stuff. I think that would be a fun next step, is to actually make your own sounds and manipulate them. Really, because you can create a really complex graph of sound effects.
So the graph contains, like the traditional filtering of sound and stuff like that.
I'll show you the graph. Hold on. I'm going to show you the graph. Supposedly. Chrome has this too, but I couldn't figure out how to enable it. But basically, it gives you basically a visualization. You can't do much with it, but you can at least see what's going on. It's super loud. And you can see as I'm connecting. This is like a game from the train that's just sort of floating there off in space. Oops. Yeah, you don't get a lot of information, but you can see how it might start being interesting. It gives you a little information, and that's about it. You can't actually manipulate anything. And when we pause, we turn off that audio buffer. Like I said, they basically get destroyed. We make it. It's a cool tool.
I can't tell from here because of the brightness, I think, of the screen. Are those actually, is it displaying connections between
Oh
the two?
yeah, you can't see that, can you?
That's okay. I just was.
Yeah, it looks like that's
right. Yeah.
wherever my talk is. I'd have to find it, but yeah, it gives you a graph that you can actually see stuff. Yeah. Okay. Oh, that's not visible either, is it? Bummer. There's little lines that show you these connecting. Yeah. Anything else?
So it's just one sort of question / comment. Did you find it interesting when you were looking at the can play audio type that one of the return types is maybe?
I didn't notice that.
One of the return types is maybe.
Nice. What does that mean?
It means that the browser can maybe play it. I've found in similar issues where it'll say the browser can play it, but it'll play it with pops and clicks.
Oh wow.
Or it'll be much slower in decoding.
What kind of what situation is that in? Like what browser?
I think it was originally in Firefox. It might be fixed now. I started using it in 2013.
Oh, interesting. Okay. Yeah.
But yeah, basically, it came down to the fact where I got to the point that I think I could likewise only trust the positive on OGG and then revert to MP3 for everything else.
Cool. Yeah, makes sense.
You can actually kind of see the lines now.
Yeah.
A little bit better.
Yep. Cool. Thanks.
You do.
Thanks, all.